Starting a new chapter, we're starting chapter 9, and we're going to start off with Pythagorean Theorem. This should be a review for most of you. We have the two legs of a triangle. This one is considered a leg, and this one's a leg. And the side that's opposite the right angle is always called the hypotenuse. Okay? And it's always opposite the right angle. And so if you wanted to solve either side, you plug it in for A or B, it does not matter, and C is always the longest side of the hypotenuse. Okay? So we're going to do some problems here, but before we get to that, we're going to talk about some common, these are called Pythagorean triples. If they are numbers, so for example, 3 squared plus 4 squared equals 5 squared, 3 squared is 9, 4 squared is 16, and 5 squared is 25. If you add those together, you get 25 equals 25. That is what is referred to as a Pythagorean triple. And these, everything on this page is considered a Pythagorean triple. And any numbers, as you notice, they plug x in here, but 6 is just a Pythagorean triple of 3, 4, and 5 with everything multiplied by 2. This is a Pythagorean triple with everything multiplied by 3, and so forth. This is a Pythagorean triple by 2, this one's by 3, and so forth all the way across. So these top ones are the most common Pythagorean triples, things you might want to look at. That if you square the smaller two and set them equal to the larger one squared, they should equal one another, and they are Pythagorean triple. The sides form a right triangle. Okay? So we're going to use Pythagorean theorem to find the value of x. So in doing so, we take the two sides here, we take 5 and 12. That would be our A and our B. And we're going to set it equal to C, which is always opposite the right angle, so that would be the C. And we square that, so we have 5 squared is 25, 12 squared is 144, equals x squared. 144 plus 25 is 169. And we learned that if we want to get rid of the square root, or get rid of the square, we have to square root both sides. So x is equal to the square root of 169, which is actually 13. When you square a variable, you do plus and minus, but we won't have to do the minus because you can never have a negative length measure. We can't have a negative 13 meters. So in this case, x is going to equal 13. All right? So we use Pythagorean theorem to solve for the hypotenuse in that one. Here's another problem. Now we're solving for one of the legs. So we have 7 squared plus x squared equals 14 squared. 49 plus x squared equals 256, is that right? 14 squared?
196.
196. So then we subtract 49.
14. Oh, I did subtract 49, never mind.
147. Is that what you got?
Yeah, I got 180.
So then when you square root that, 147 does not simplify nicely, but so if they want an exact answer, then you would leave it like this. If they want a decimal, you'd put it in your calculator, and you'll see that it's going to equal 12.12. And you have to look at your numbers and say, well, does that make sense? And I would say, yes, it does, because 12 is less than 14. So the two sides have to be less than the hypotenuse. So yes, that answer makes sense. All right. Looking at this right here, they want you to find the value of x. So we have our right triangle there. So we're looking for the hypotenuse, and we have two side lengths. So we have 23.36 squared plus 47.57 squared equals x squared. And when we do that, we get, if we add those together, we get 2808.6 equals x squared, and then we would just square root that. And we're going to get x equals 52.99. And I would probably leave it where they went 2 decimal places here. I would probably leave it like that. And we would have to ask ourselves, does that make sense? And it's more than 47 and it's more than 23. So yes, it's the hypotenuse, it's the longest side. So 52.99. So that's how you use Pythagorean theorem to help you find the length of that right there. Here's just a couple practice problems. Once again, we've already done these. 4 squared plus 6 squared equals x squared. So we have 16 plus 36. And we get x squared equals 52. So the square root of 52. I mean, you guys can type that into your calculator, but this would be 3 squared plus x squared equals 5 squared. 9 plus x squared equals 25. Subtract 9, and x squared equals 16. So when you square root that, square root of 16 is 4. So x equals 4. And yes, that is a Pythagorean triple 3, 4, 5. This one is not because it'd be the square root of 52. Okay? The other thing you can do is they can give you 3 numbers and say, does this form a right triangle? Okay? So looking at this, we would just plug these into the Pythagorean theorem. 7 squared plus 8 squared equals the square root of 113 squared. What happens to the square root when you square it? It goes away. So that equals 113. And this is 49 and 64. And what do you know? We have 113 equals 113. So yes, that is a right triangle based on the Pythagorean theorem. We do the same thing here. We have 36 squared plus 15 squared equals 4 squared is 95 all squared. This is 16 times 95, which is a pretty big number. And 36 squared works out to be 1521, and 16 times 95 is 1520. Those two do not equal one another, so this is not a right triangle. Not a right triangle, okay, because they're not equal. All right. This would be the same thing, again, just checking those and making sure those are 9 squared plus 15 squared equals 3 squared is 34 all squared. So when you're squaring this problem here, you have to go 3 squared, which is 9, and you have to multiply it by the 34. This is 81 plus, is 15 225? I think it is. So this is 306, and 9 times 34 is also 306. So yes, that is a Pythagorean triple. You can do the same thing here. 14 squared plus 22 squared equals 26. How do you know what numbers to put where? And that is, yes, you can look at it, but you put the smaller 2 numbers together and set them equal to the larger number, and that's what you're checking for. And 14 squared plus 22 squared is 680. And 26 squared is 676. So no, they are not equal for one another, so this is not a right triangle. Okay? All right, the last thing today is telling if a triangle is acute or obtuse. So now we look at this inequality. If the c squared is less than these two added together squared, then it is an acute triangle. If c squared is greater than, then it's an obtuse triangle. So you get the c on the left-hand side, and you see if it's less than or greater than, and that's going to tell you if it's an acute or an obtuse triangle. So looking at this, here's our side lengths. So we take the largest one, which is 6.1, and we're going to see what it is at greater than, less than. The other two, got to square them. So when we do that in our calculator, we have 6.1 squared, which is 37.21. And we're still waiting to see what 4.3 squared plus, this is 45.53. So c squared is less than these two added together, so this triangle would be acute. Okay? And that is because this is less than. The c is less than the other two added together. Okay? Let's try another one here. We have 3, 4, and 6. So we have 6 squared, and we're looking at 3 squared plus 4 squared. This is 9 plus 16, which is 25. This is 36 is going to be greater than, so that one is going to be obtuse. Okay. We can verify this one right here as well. We have 3.5 squared, and we have 2.1 squared plus 2.8 squared. We have 2.1 squared plus 2.8 squared is 12.25, and 3.5 squared is also 12.25. So it's not greater than, it's not less than, it is equal to. So any idea is what it is when it's equal to, that should tell you it's a Pythagorean triple. So it is a right triangle in this case. It's this option right here. So if it's less than, it's acute. If it's greater than, it's obtuse. And that is the lesson for today. Look over that and go ahead and answer the questions. Hope you have a good spring break. And we'll be with you tomorrow.
Okay, I'm leaving it right there for you to save it.
Okay.
Since you have the magic save.
I don't know about the magic, but we'll get it done.
Okay, so this will be chapter 9 in the module, right? Okay.
Yeah, I gotta go through and create that module.
Okay, we're gonna be back in May, right? I hope.
I don't know. I hope so. I'll go nuts if we're still into May.
Well, I will, because the community also looks, are you working? What are you
Right.
doing? Why are you still getting a paycheck?
Well, that's the hardest thing is because I was walking around. I went from here yesterday at 11 o'clock. I went over to Lee's and picked up 2 or 3 things, then went home. But all while I'm in Lee's, people, oh, that's a teacher.
Yeah.
You know.
I mean, it's that kind of thing, but yet they don't see that, like when I went